My name is Mark McCorkle.
Hi, my name is Nathaniel Long, and this is our GoPro camera skateboard mount design project.
The main goal of this project was to determine the best material and design for a GoPro skateboard mount that would protrude from the front of the skateboard in between the trucks and the skateboard deck.
So the problems we had in facing this design challenge and selecting the material were impact forces in between the trucks and the skateboard, exceeding up to 1,200 pounds. We also had a weight concern. We wanted to make sure the mount was no more than 1.25 pounds, otherwise it would encumber the rider. And then there was also fatigue from vibration. As you can see here, the camera is sitting on the end of the part. We needed to make sure the material had a high enough fatigue strength to withstand the wear and tear from that.
Other problems were the camera angle. We needed to have the whole board in. We wanted to have the whole board in, and it needed to be adjustable, different size boards, things like that. Some corrosion resistance, not a huge factor, but it is going to be used outside, and it, of course, needs to be affordable.
Here's some previous solutions we found. With both solutions, they encumber the rider or are only usable on longboards, as you can see here. This one gives limited viewability as well as this one, and this solution seems to be made out of plastic, which is weaker. We were both dissatisfied with these solutions, so we decided to design our own. We used Credo Parametric to draw up a CAD design of the part. We dimensioned off the actual skateboard and drew sketches, came up with this design.
So here's an actual drawing with dimensions, and in the design we wanted to make sure we avoided rapid changes in contour to keep it strong. We tried to take off as much material as we could in places that wouldn't affect performance to keep it lightweight, and we tried to avoid machining complications like small radiuses in here or stuff that might take too long, because that makes it more expensive.
Here's our material comparison chart. This is where we tabulated all of our findings and gave it an application grade. We looked at modulus of elasticity, fatigue strength, shear modulus, hardness, which is how we factored in the machinability, and as well as the cost. And then one of the highest rated categories was our density. So we wanted the part to be lightweight. For the steels, both the cold rolled and the hot rolled, extremely strong, high shear modulus and modulus of elasticity. Fatigue strength, like we said, was not really a factor because it's so strong. Hardness, however, made it difficult to machine, and while it was cheap, the density was so high that we gave it a D.
With the aluminums, you can see they're pretty similar. 2024 aluminum is a lot stronger. It would be ideal, except for that it's expensive. A lot more expensive than 6061. The shear modulus for both of them is alright, but for this application there's not as much shear force on as there is compressive force. The ABS plastic, however, did terrible, and the only thing good about it is that it's lightweight and it was easy to machine. So we chose to use 6061 aluminum as you can see, we got an A, and after choosing the material we decided to actually have it machined. So just for fun, we had it quoted by Austin Precision Machine Shop. It's a $100 setup fee, and then it comes out to about $30 a part. So a little bit more expensive than what we were hoping for, but it's a prototype. We know what we're doing. This does include material cost, and if we had used a more expensive material like 2024 aluminum, this would reflect that.
In conclusion, the properties of the material we selected, which was 6061 aluminum, fit perfectly with the application we had. The weight, fatigue strength, and cost, as well as its shear modulus and modulus of elasticity, were all within what we were looking for. The aluminum allowed for the production because of these properties of the actual part, and the design of the part exceeded what we were expecting, along with the properties of the aluminum.
Some things we might do in the future to change is we might change the design. That back part, the plate with all the complicated angles, took about 4 minutes to machine. So if we made that into some window, circle, or something, it would be just as strong and light, and it wouldn't take 4 minutes to be cheaper. We could design a more universal mounting system to incorporate other cameras, a simpler one, and we could get anodized colors protection, and that's our project.